In this video, I'm going to go over two problems on the homework, number 2 and number 5 on the 320 homework. So number 2, I'm going to draw a nice triangle first. And this is going to be an equilateral triangle, and I'm going to draw it nice and big. And I know on the homework it used a radius of 2, but I'm not going to do that exact one. I'm going to draw in a radius of 6 instead. All right, so the homework problem did say that this was a regular polygon. Therefore, that means all sides in this polygon are equal. So I'm going to mark them as equal. So I need to break up my triangle into smaller triangles. So I'm going to continue to draw the radius into all of my vertices, and then I'm going to go ahead and figure out the measure of one of these angles. I know if I continue and go all the way around this circle, that's 360 degrees, but I broke this circle up into 3 equal parts. So I'm going to find the measure of one of those. That's 360 degrees divided by 3 equal parts. It's 120 degrees in one of these parts. All right, so in order to find the area of this triangle, the formula equals 1/2 the apothem times the perimeter. And unfortunately, I don't know the apothem and I don't know the perimeter because they only gave me the radius. So what am I going to have to do? I am going to have to break this problem down, and I'm going to have to draw in my apothem. And when I draw my apothem in, it splits this red angle into 2. So now let's go ahead and redraw this triangle here. And the other thing I wanted to mention is your apothem always makes a right angle with the side of your regular polygon. The right angle is never the central angle. It's never the red angle here. It's always with respect to the side of your regular polygon. So I know each one of these radii is 6. And if I split my red angle here in half, this angle here is 60 degrees. So how do I solve the other two sides of this triangle? Well, it's a 30, 60, 90 triangle, so I'm going to use my rules for 30, 60, 90. To go from the hypotenuse to the short leg, I just divide by 2, so I get 3. To go from the short leg to the long leg, I multiply by radical 3, so I get 3 radical 3. So this is going to be my apothem, this guy right here. The guy that makes a right angle with one of the sides, that's my apothem. So my apothem has a measure of 3. So I have my apothem. We just need to find the perimeter now. How do I find the perimeter? Well, I know this part is 3 radical 3 because I found it when I was solving my 30, 60, 90 triangle, which means this is 3 radical 3. So the entire length, I would just add them. I would get 6 radical 3. And I have 3 sides to my triangle, so when I multiply by 3, I get 18 radical 3. So my perimeter is 18 radical 3. So now I'm going to reduce by 2, and 9 times 3 is 27 radical 3. And that's how you should be doing problem number 2, but instead your radius is going to be 2, so you'll be solving a little bit different numbers in that one. Okay, so let's take a look at problem number 5. Instead of using an octagon, I'm going to start off and say it's a decagon. So that is a 10-sided figure. And that is going to be hard to draw, but I'm going to try it. I've got one side here, one side here, one 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 here, and one here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. So when I find the center, I'm going to divide, I'm going to draw in all my radii. and it divides my decagon into 10 equal triangles. So how much is one of these angles in here? Well, I know if I go around the complete circle again, that's 360 degrees, and I'm dividing that into 10 equal parts. So one of those angles is only 36 degrees. So now, how do I find this bottom angle? The angle made by a radius, and one of the sides of my decagon. Well, I'm going to go ahead and I'm going to draw this triangle that we found, and I'm going to make it a little bit bigger. And I know that this angle right here is 36 degrees. And I need to find this angle here. So what I'm going to do is I'm going to drop an altitude down, and I'm going to split my triangle in half. So when I split my triangle in half, this angle here becomes 18. This is a nice right angle, because this, when I drop this, that is my apothem, and my apothem always makes a right angle with the side of my regular polygon. And we know that the measures, or the sum of all the interior angles of a triangle, add up to 180. So 18 degrees plus 90 degrees plus, and I don't know that one, I'll call it x, must equal 180. So then I get 108 plus x equals 180. And when I subtract 108 on both sides, I get 72 degrees. This little angle down here is 72 degrees. 72 degrees. And that's how you should be working number 8. Instead of a decagon, you're going to be dividing. You have an octagon, a regular octagon, and you'll be dividing that octagon into 8 equal triangles instead. All right?